How are you doing, everybody? I'm at the Biophysical Economics Conference 2016 in Washington, and today we're going to do a special impromptu interview of Jurgen Mimkes, who is with the physics department of Paderborn University, and his talk was on calculus-based bioeconophysics, a synthesis of social and natural sciences. So, Jurgen, how did you get involved back in the 1990s? How did you get engaged into social and natural sciences integrated?
Well, in 1990, I had been chairman of the department, and in the same time, we were shocked by the killing of right-wing people and killing Turkish people who had come to Germany. And we all were shocked because we all said, are there Nazis coming back, killing people from other countries or from other beliefs? And I asked for a meeting in our department and invited everybody to discuss this. And I thought myself, the only basis I can do this is on a scientific basis. I could try to find out the mechanism of hate or of these feelings. And in the way of processing this, I found a paper, a newspaper's clip from the state of Bosnia. The war had just been going on, and it showed a map of Bosnian and Serbian people, and the map looked exactly like a piece of metal I had just prepared for my class. The piece of brass. Brass is a binary system of copper and zinc, and this binary system looked exactly like the one in the newspaper, a binary system of Muslims and Christians in Bosnia, and they had the same structure. And I wondered, because I could understand the metal very well, how this happened, but we didn't understand why the war in Bosnia was going on. So I thought maybe there are the same structural reasons for this, and I tried to fit the data from Bosnia into my models of alloys, and it turned out we could do exactly the same structure by modeling this. And then I went into more interesting binary systems. We had Catholics and Protestants for many centuries fighting against each other in Germany. So I put up a phase diagram of binary marriages in the United States of black and white, in Germany of Catholics and Protestants, and also of German and non-Germans. And they turned out to have the same phase diagram as binary alloys do, like gold and platinum or copper and zinc. So I figured there must be something thermodynamic behind this behavior. And this is how I started to invest in human societies. And by the time going into this, involving into this, I found it much more interesting actually to deal with people on a very scientific way than with atoms. So I'm now really fully trying to understand how people behave and how we can explain this on the basis of thermodynamical equations.
Okay, that's very discerning viewpoints. So back when you were studying the phase diagrams of the separation of the binary alloys, what sort of scientific principles, physical principles, thermodynamic principles were you teaching students, and how
I will show this later here. In this
okay. All right. Sounds good.
Slides.
I like the. So your first paper then was which one?
The first one was binary alloys as a model for the multicultural society.
Excellent. Very famous paper. That was in 1992.
Yes. This
yes.
was in 1990.
Okay.
92 or 93, that time at least. Yes.
All right.
And from then on, I thought, well, if thermodynamics works so well in societies, it must also work in economics, because economics and societies are very closely connected. And so I started to go into basic economics and trying to set up laws, and I found that we can use the thermodynamic laws of the first and second law and apply these to economics, and we obtain nearly everything we want to know from this if we understand it right.
Okay, and in the 1990s you were the chair of the department? The chairperson?
Yes, in 1991 to 1993 I was chair.
Okay, so there was, did you have any, were people objecting to any of this application?
Well, my first publication, I had given another talk on this then on a conference in Prague, and my colleague in Prague was going to publish this on alloys. This was a conference on alloys. He was going to publish this in a physical science paper, and the paper refused my talk and said, this is not physics. And so my colleague said, well, this is part of the conference, and we want it published there. And he refused to publish it, and so my colleague said, well, then we will withdraw all our talks from the conference and look for another editor and find another book.
That's excellent.
We did, and from that on, I was very grateful to my colleague that he persisted. Because
and what was your colleague's name?
Jaroslav Šestak.
Excellent.
He is a physics, and he's also in chemistry, actually, at the chemistry department in the Czech Academy of Science, and he's also teaching now at the American University in Prague.
Okay. To put things into context, what Mimkes has done here is a rather pioneering effort. Historically, the first person to attempt to get a social physics program initiated was Florence Nightingale, who for nearly 2 decades, from 1874 to 1891, attempted to get a Quetelet-based social physics program initiated at Oxford, to no avail. She was followed by American physicist John Q. Stewart, who teamed up with thermodynamicist Percy Bridgman to get a social physics program launched at Princeton. Their efforts, however, were stifled by the theological objections of Warren Weaver, who funded their project from 1949 to 1953, but cut funding on the 4th year owing to objections that one could not measure things such as values or aesthetics or morals according to energy and thermodynamics. Accordingly, what Mimkes has done since 1992, basing Socio-Economics on Goethe and Empedocles Willard Gibbs based physical thermodynamical models of societal and economic interactions, is a large step forward in terms of generations of social physics pioneers, as Arthur Eberl describes things, who himself attempted to get a social physics program going at UCLA with little result. Mimkes, in his Thermodynamics-Based Physical Socioeconomics Research Group at Paderborn University, in 2002 produced 2 master's degrees students, one by Christian Thought on an analysis of integration problems of society with the methods of physics, and another by Thorstein Frund, analysis of income, wealth, and society by physical methods, which is something inconceivable in present-day America, where, for example, the American Physics Society does not even recognize sociophysics as a discipline. To conclude, if thought is capable of being classified with electricity, or will with chemical affinity, aka Gibbs energies, in post-1923 modern chemical thermodynamics terms, as a mode of motion, as American physical chemistry-based historian Henry Adams opined over a century ago in his A Letter to American Teachers of History, which is a supposition that resulted in Stewart and Bridgman getting their funding cut for their Princeton social physics group, which is a supposition that Mimkes has advanced in the last 2 decades at Paderborn University, then it seems to be a supposition necessary to fall at once under the second law of thermodynamics. Of all possible theories, this is likely to prove the most fatal to professors in general and to professors of history in particular. This highlights the century-plus backwardsness of the American educational system, which, for example, does not even recognize social physics as an academic discipline. Hence, we commend Mimkes in his pioneering efforts in this direction.